Welcome to Ask and Learn.
All right, for part A, we want to answer the question, how many positive integers between 1,000 and 9,999, are inclusive, are divisible by 9? So what we can do here is figure out first how many positive integers less than 9,999, I suppose less than or equal to, are divisible by 9. So we do the floor of 9,999 divided by 9. It's going to be an integer anyways, but that is 1,111. Then we need to subtract off the number of integers less than 1,000 that are divisible by 9. And that is going to be, one second here, 111. So the answer is going to be 1,111 minus 111, which is, of course, equal to 1,000. For the next part, we want to answer how many are even. So to find the number of even numbers, even positive integers, we would do 9,999 divided by 2, round down. That's going to give us 4,999. Then we would take 1,000 divided by 2. Round down, though this is going to be an integer, we have 500. Now we need to be careful here. It's not the number of even numbers between 9,999 and 1,000 isn't just going to be 4,999 minus 500, because 1,000 itself is within our interval as well as being an even number. So it would actually be 4,999 plus 1 minus 500, or 5,000 minus 500, giving us 4,500. For part C, we want to answer how many have distinct digits. Now, for figuring out the number with distinct digits, we want to consider essentially having little boxes that we're filling in with our numbers. The first box, well, we can't have 0. 0 is not an option. We can only have between 1 and 9. So we have 9 choices. Then for our second box, actually I suppose I shouldn't put 9 in that box. For our second box, we can choose anything between 0 and 9, except for what we put into the first box. So we have 10 choices minus 1. So we'd have 9 again. Similar thing for the next box, we would have 10 choices minus 2. So times 8. And then we'd have 10 choices minus 3, so we have times 7. 9 times 9 times 8 times 7 is equal to 4,536. Next, we want to answer how many are not divisible by 3. So that's going to be equal to 9,000, the total number of positive integers just within. Actually, it would be, one second. So there are 9,000 positive integers between 1,000 and 9,999. Then, we want to subtract off all of the integers less than 9,999, which are divisible by 3. And then we are going to need to essentially add back in all of the integers less than 9,000 or less than 1,000, which are divisible by 3. Essentially, when we subtract off all of the integers less than 9,999, which are divisible by 3, we'll be taking away too many elements. So, do that, which is going to be the same thing as 9,000 minus 3,333 plus 333 which is going to give us 6,000. Now, for the number that are divisible by 5 or 7, keep in mind, if we want to find out the number of things in set A or set B, that's equal to the number of things in set A plus the number of things in set B minus the things in the intersection of set A and B. So we want to find the number that are divisible by 5, add on the number that are divisible by 7, then subtract off the number that are divisible by both. So for divisible by 5 would be 9,999 over 5, round down, minus 1,000 over 5, which is going to give us 1,799. We will need to be careful here because 1,000 itself is divisible by 5. So I'll note that divisible by 5, divisible by 5, that number is going to be 1,800 because we need to add back in 1,000. 1,000 referring to the number. We need to add that back into our set of valid options. The size of the overall set is going to be 1,800. Then the number divisible by 7, similar deal, except for we won't have to do that reaccounting for the end point. But we'd have 9,999 divided by 7, round down, minus 1,000 divided by 7, round down, which is equal to 1,286. And lastly, we need to do to determine the number that are divisible by both. We do 9,999 divided by 5 times 7, round down, minus 1,000 divided by 5 times 7, round down. That equals 257. So the total number divisible by 5 or 7 is equal to 1,800 1,800 plus 1,286 minus 257. That is going to give us 1,543 as our total there. For part F, we want to answer how many are not divisible by either 5 or 7. Excuse me, I need to jump back a second here because I just realized I wrote down the wrong number. Actually, 1,800 plus 1,286 minus 257 is going to be 2,829. Excuse me. To determine the number that are not divisible by either 5 or 7, we just need to take the number or the total number of integers between 1,009 and 9,999 and subtract off what we found in E. So there are 9,000 possible integers. We subtract off 2,829, and that is going to give us 6,171. For part G, we want to find the number that are divisible by 5 but not by 7. Well, that is just going to be 1,000. So that would be, we can figure it out by taking the number that are divisible by 5 and subtracting off the number that are divisible by 5 and 7. So that would be 1,800. That's the number divisible by 5. And then we found that the number divisible by 5 and 7 is 257. So the number is 1,543. And lastly, part H, this is actually something we figured out as part of trying to answer the previous question, part E. So the number that are divisible by 5 and 7 was 257.